what we're going to do today is talk about your final, and maybe whatever time we've got left, we can do some topics. Monday is a class day, so if you turn up on Monday, bring questions with you and we'll go over those, get you ready for the final. But Monday is a open day or an optional day. I'm giving you attendance for turning up regardless. You can turn up on Monday, get the question you want answered, and then go away and continue your revision, right? It's whatever you want to do. That's what open-ended means, whatever you want to do. And so that's kind of what Monday's about. And our final, double check it, is on Thursday. So after Monday, Tuesday, Wednesday, I ain't going to be available because I'll be supervising finals and grading. So I'll try and check my email from now, now and again, but I definitely won't get back to you quickly. So just put that out there for you. So are you looking at our Canvas page right now? So that's what's on the screen. Okay. So let's click on this one. And it kind of gives you all the important things in one place. I'm going to see if I can make this a little bit easier to read. Okay. So everything you need to know or are able to use, you'll get on Canvas on this one module, right? That's where it will be, including this thing I'm reading from. Your exam starts at 10 and finishes at 1, right? So make sure that you set your alarm or whatever 1 hour early. So it's not an 11 o'clock start, it's a 10 o'clock start. Your exam you will get is going to be as a PDF. And it's going to be in 2 sections. Section 1 is going to be multiple choice, 5 points each, so that's 50 points. The multiple choice section tends to be the worst done section historically, so be careful. Section 2 will have 10 questions in it, and they will average 25 points. Some are 20, some are 25, or some are 30, but on average 25, and that's the other 250. So you can see that your exam is going to be out of 300 points. Now, sometime this weekend, I guarantee it, there I force myself, I guarantee you will get a report. And the report will tell you everything that I know up to, but not including test 10 and the last bunch of homework. It'll tell you your grade. And lastly, it will have how many points you need in your final out of 300 to get a 2.0, a 3.0, or if your goal is a 4.0. So that'll be something you haven't got yet. The final has a format that is very like the midterm, right? Multiple choice. All I want in the multiple choice is the answer, no working. So question 2, it's A, question 3, it's C. Don't show me it, don't need to see it. On section 2, I need to see working, unless a piece of it was because you went and looked up GeoGebra, right? You visualized it, right? But for the most part, I'll see working. And the final exam is cumulative. So here are the topics. And we start with directional derivatives. So way back in the day, remember those guys? Directional derivatives, week 1. Actually, there's a couple of sections in the head of that, but we talked about that last time, isn't it? The partial derivative stuff that was floating about, but you've got that stuff. That's the important stuff here, right? We'll assume that you know all the, well, you need to know how to do partial derivatives in all sorts of places, so I'm not going to ask it off the top of my head. I think last time we had Lagrange multipliers, didn't we? Someone asked us about them, but it goes all the way down to divergence theorem, and it's in chronological order from week 1 to week 10. Here is the link to Zoom. Once you're finished, you have got 30 minutes to upload your working. These are the things you can use. You can use your TI, any kind of physical written notes, lots of formula, write everyone you can think down, have things like your unit circle. And you got to sometimes remember that Calc 1 and Calc 2 is stuff you need. to know. If I went and said to you, what is the integral of 1 over 1 plus x squared? Right. What is the integral of 1 over 1 plus x squared?
Isn't it arctangent?
Or, as I prefer, inverse tangent. Yes. But can you imagine you didn't know that and hadn't written it down? Aren't you going to have a big problem trying to do that? So, you know, when you do triple integrals and so on, aren't you going to eventually integrate things the calc 2 way, right? And so you've got to remember u subs, integration by parts, and when they are appropriate, right? When you use one method over the other. And don't you also need to know exact values, like what is the sine of pi upon 4, because the limits from 0 to pi upon 2 or pi upon 4. So all those calc 1 and calc 2 things, you know, have formulas for them, write them down, you'll use them. Don't use a calculator that has algebraic manipulation. If you don't know what it is, you're safe. Don't use it to talk to people, to do tutoring, and don't do anything communication-wise. So don't phone them, email them, or any other method. Right. We kind of cool with all this stuff. Right. And then I've mentioned, is there any questions that have came to you that I might not have covered the last time I did?
Are you asking for ones that we want to see done?
Yeah, we'll do that in a minute, but just something to do with the format of the final or anything specific that you're not sure about. Okay, well then we are ready. What's your first topic? Pick someone, we'll get started. What do you want me to do?
Lagrange multipliers.
More Lagrange multipliers. Those guys are a pain, evidently. Okay.
Can I ask a quick question? I should
Sure.
have checked this from yesterday, but are you recording these and uploading these as well?
Yes.
Okay, thank you.
Let me find specific questions. Is there a question you've got in mind? That would be really good, because I could pick one and it's not kind of the problem that you're having with Lagrange, it's something else. Or if you don't, then I'm just going to go. I'm going into Lagrange right now just to pick one of their questions, just so that it's doable.
I don't have a specific, but if anybody else is specific, then
right.
I'm trying to get into WebAssign right now to go find one.
Right. Okay. Doing the same. Past assignments.
Can you make it so that our last couple of tests are viewable? I can't view them for whatever reason.
Yes. Let me take a look now at that. I thought I'd done that, but I haven't. Yeah, that will disappear on the day of the final, but up to the final, you'll be able to see all those things. Okay, so I'm now in Lagrange multipliers. I'll pick at random question 9. Ooh, I could do 9, but it's weird. Let's do 8. Did I do 8 last time? Probably not. Okay, this is question 8. 9 was too essentially simple. So let me kick over to the screen and kind of go through the process. So what you're given is a function x squared plus y squared plus z squared. And we want to find the max and min value. And the constraint function is that we want to find what the biggest value for this expression is. But the constraint is that x to the 4 plus y to the 4 plus z to the 4 is equal to 7. And so this function has a lot of symmetry to it, which is fine. This bit here, I'm going to call G. Okay. So Lagrange found out that the gradient of f equal to lambda, the gradient of the constraint function G. If you solve that equation, you will be able to find the places where the maximum and minimum of this lie. So essentially, we're going to try and find out combinations of x, y, and z that work for this equation. So this fella is the partial derivative of x with y and with z. So this is a three-dimensional one, and it's lambda and I guess g of x, g of y, g of z. And of course, a two-dimensional version of that would just have those two missing. And a lot of symmetry going on. This one is 2x, this one is 2y, and this one is 2z. This one is 4x cubed, 4y cubed, and 4z cubed. And when you compare the x's, you get 2x is 4 lambda x cubed, 2y is 4 lambda y cubed, and 2z is 4 lambda z cubed, which is nice. First thing I'm going to do is I'm going to test, does lambda equal 0 give me a viable solution? Well, if you make lambda 0, you essentially end up with x, y, and 0 all being 0 as well. So a potential critical number would be the origin. You go to the constraint function and you see, does 0, 0, 0 equal that? And the answer is no. So you're not usable. I'll then go to these equations. I'll call them 1, 2, and 3. And I'm going to take equation 1 and divide it by equation 2. And equation 1 is 4 lambda x cubed, oops, do it in order, 2x over 2y equals 4 lambda x cubed over 4 lambda y cubed. And if you cancel and simplify, you get that. If you cancel and simplify, you get that. Now, if you cross multiply, you get xy cubed equals x cubed y. If you subtract from both sides, now, can you pull out any common factor here?
You'll pull out xy.
Okay. Essentially, we need to factor this, because if you get something equals 0 and you factor the something, won't that lead you to solutions? So what I'm going to get here is y squared take away x squared equals 0. Okay. Now that leads to a number of possible solutions. One of them is x equals 0. One of them is y equals 0. And the third one is that y squared minus x squared equals 0. Now I'm going to kill off, I think I'm going to kill off these two, because they basically eventually get you the origin. So I'm not interested in those. This, however, is interesting because it does give me a relationship I might be able to use. And we've got that. But that is equivalent to y could be x and y could be negative x. Okay. So I can use this or I can use that, right? It's a start. If I then take equation 1 and divide it by equation 3, I get 2x over 2z, and I get 4 lambda x cubed over 4 lambda z cubed. So far, so good. Now, I'm really kind of duplicating a lot of what I did in the first one, right? And I would do this, and I do this, and I do this. Can you just cut to the chase and say that I'm going to end up with that relationship? Can you imagine? Same kind of math, same kind of solution, which means that that is true. Or if I wanted to, I guess I could write it something like this. Now I'm going to take this fella and this fella. And I'm now going to use it on the constraint function. So the constraint function is x to the 4 plus y to the 4 plus z to the 4 equals 7. Now, if I use this piece of information and this piece of information, can I turn the y squared into x squared? So what am I going to get? I'm going to get 4 y squared squared, z squared squared equals 7. I'm going to get x to the 4 plus x squared squared. Probably I'm making a meal of this. And that gets me 3x to the 4 equals 7. That gets me x to the 4 is 7/3. And that gets me x is plus or minus. Why on earth is this not a nice number? God in Himmel. I do not know why that's not a nice number, because don't they normally make these numbers pretty? But evidently I got the bad red number. Are you comfortable with that being the 4th root of 7/3? Right, so what do we know? Well, we know x could be the positive 4th of that one, right? We know x could be the negative, the 4th root of that guy. When x is this, couldn't the y be the same value? Or it could be the negative of it. And couldn't z be the same value or the negative of it? And if I did this one, you'd get the same. So I'm going to improvise this as plus or minus that guy, plus or minus that guy, plus or minus that guy. Would you agree that's just a convenient way of writing down 8 different combinations? Right. Now, every single one of them gets evaluated by calculating the value of f. So if I find the value of x, y, z at every single one of those points, so that's going to be x squared plus y squared plus z squared, I am going to get the 4th root of 7/3 squared, the 4th root of 7/3 squared, and the 4th root of 7/3 squared, which ends up being the square root of 7/3, square root of 7/3, square root of 7/3, which means you get 3 of them. I can split that as a root 7 over root 3. If I rationalize the denominator, I will get 3 times the square root of 21 over 3. And would you believe it, it's actually a reasonable answer. It's the square root of 21. So in that particular question, it doesn't matter if you put a plus or minus any of those. Don't you end up with the same answer? You end up with the square root of 21. So what was that? Was that question 10?
Question
No.
8.
Question 8. Okay. So we got that one. And evidently, there is a square root of 7, which is the minimum. Well, where the heck did that come from?
Would that be if x and y are 0?
That is exactly it is. So if you do a 0, 0, 4th root of 7, 0, oh, they're both 0, right? If you do that guy, right, that one will get you nothing squared plus nothing squared plus that guy squared, which is the square root of 7. Okay. So see when I kicked out that 0, 0 because I thought it was the origin? Well, 0, 0, 0 is the origin, but 0, 0 square root of 7 does work, right? That is our 0, 0 4th root of 7. That does work as a critical number. So that's where I missed the root 7 from, but we got him. Can you see why that is one entire question in your term, in your final, right? There's not really an A, B, C in that because the amount of work, right? Some questions have an A, B, C, either because I'm helping you to do the process. Can you imagine I might ask you to find the divergence of a vector field because we're going to use it to do the divergence theorem to find a line integral, right? So A might be what's the divergence, something like that. Are we good with that question? I think it was Will. Was it you who asked it, Will? Is it just the complexity of the process and the fact that you have to adjust to the situation, what you're getting? The strategy of 1 divided by 2 and 1 divided by 3 is pretty good way of doing it. I know if you look up solutions, there are other ways to do it, but for me, that way seems to work the best. And the reason it works well is, doesn't the dividing get rid of the lambda problem?
Right.
And one less variable is always going to be a good thing. What you tend to get, of course, is not that x is 2, but don't you get things like x is y squared, or x is 2y, or you get some kind of relationship. But if you do it, you will be able to turn your original function into nothing but x's. Right, and that allows you then to solve, because when you put it into here, at least I should say, it allows you to solve it. And you know, x squared plus x squared plus x squared gets you 7, right? You'll be able to get an answer. Okay, next question. What do you want to do?
I got one.
Say again?
I said I got one.
Okay, go for it.
I'm in 16.2, question number 8 for me, and I can just read it out for you.
Perfect.
Evaluate the line integral. F over the region C of f dot dr, where C is given by the vector function r. F of xyz equals sine of xi plus cosine of yj plus xz of k.
Right, I'm not
R.
writing. Right. R of t
Sorry.
is it R of t? Are you doing a space
Yeah, it's
curve?
R of t is e to the 4th I.
E to the 4?
Yep, e to the power 4.
Oh, just a number then. Okay, next.
Oh no, I'm sorry. T to the 4th. Yeah,
You've
T
got-
is in tango.
Okay.
Minus
Next.
t to the 3rd plus t. Those are your, I took the I die k out.
Okay, we're having a problem with the English language here. Do you mean that or do you mean that?
I mean the bottom one.
Okay. When you say third, I hear 1/3, which is a fraction.
Yes, I should have said cubed.
That would have saved us all problem. Anyway, I'm going to write this as a mess and rewrite it cleanly. So what's the next term going to be?
Those are the 3 terms. Just put your
Oh,
comma
okay.
right before the plus sign.
I got it. Okay. So what
Then
we are, what's
the
the range
function?
of t's?
That's the range of t's. The function is sine of x. I'm not going to give it to you I'm not going to give it to you an ijk. Cosine of y. So yeah, comma cosine y, and then it's xz is the k.
Okay, we're good. So
That's it.
we're being asked to find a line integral over curve C. Curve C is basically some kind of twisting polynomial. It needs a start and finish value. So where does t begin and finish for the space curve? Does it say 0 to 1, which it almost always does, but does it have a start and finish?
It's 0 to 1. I'm sorry, I keep talking, but my mic was muted, and then I realized you couldn't hear me.
Right, and in this case, we've got this fella here. That's empty f, and it's a sine t, sine x, cosine y, xz. Right. So the formula that we're going to use is, I guess it's written down something like this. So essentially we turn it into a normal calc to integral. And so we have to figure out, what does this mean? What does that mean? And so on. First, r dash t is simply just the derivative of the space curve. So it's going to be 4t cubed, take away negative 3t squared, 1. And f, that's this guy, in terms of t, basically what you do here is you find the sine of x, but replace the x with that guy. So it now becomes the sine of t to the 4. Cosine y becomes the cosine of this guy, so it becomes the cosine of negative t cubed. And xz becomes that guy times that guy, xz, which becomes t to the 5. So we are going to be doing the integral from 0 to 1 of the dot product of this guy with the derivative, which is this guy, dt. Right, dot product. First times first, second times second, third times third. So, put my little comment in. Here it goes.
Yes, I know this one. This one was nice because the use subs work out really nicely.
It does look that way. I agree with you.
How did t become t to the 5th?
I multiplied x times z together, and t to the 4 times another t gave me t to the 5. See, in f, the third term is xz, right? The third term of the vector field was xz. X is this guy, z is that guy. So when you multiply these together, that's t to the 5. And just like you said here, you would probably break this into 3 separate integrals, wouldn't you? For computation reasons. So you would probably do this fella first. Probably take away that guy. And that guy's the only easy one, so I'll do that right now. Okay. U sub for this fella would be t to the 4, and it comes out quite nice. U sub for this one would be, I'd probably do negative t cubed, and it comes out nice. This one's done. Once you get the answer and convert them back into t's, just put t equals 1 in, and then t equals 0 in, and the difference between them would be the value of that line integral.
Thank you. I actually see where I made my mistake.
Right. If you were given an exam question on this, this technique works perfectly fine. If you checked, you could do this in other ways, but I would think the way the information is given here, this would be the least amount of work. But can you imagine that this function was a conservative field? Right. So if this vector function was in fact a conservative field, you'd have to do that with the 3D test bit, you know, the curl of f is the 0 vector, right? But let's suppose you did that, guy. Couldn't you just find the coordinates of where it started and the coordinates where it finished in terms of f of the potential function? So you'd have to find little baby f. So there could be a much more convoluted way to do that one. So always think lazy. Always think, what's the quickest and most efficient way I can get the answer? Because that's going to be a good strategy. Of course, if I tell you use the divergence theorem to do something, you must use the divergence theorem, right? If I tell you use Stokes' theorem to do this, you must use Stokes' theorem. Mostly because that's the best way to do it, but also because I want to see, do you know how to do Stokes' theorem? But if a question just says, find this, technically can't you use any method you like as long as it works? But try and use the one with the least amount of work.
Thank you.
Okay, where are we off to now?
We do some spherical.
Sphericals, yeah, they're a pain in the butt because I never remember them totally. I mean, what's the word I'm looking for? The formula.
Yeah, and they're annoying to write too.
They
like
are a
sideways
pain in the
P
butt. And
squiggly.
phi and thetas. So just write the damn thing down in a card so that when you hit it, if you hit it, it's in front of you. So I'm picking it. Have you got a number to do? Otherwise,
Yeah,
which one?
it was 11 on 15.8.
Okay, I got that one up. 11:15.8 coming up. Find the volume of a solid that lies within the sphere. Well, it's going to take a bit of thinking. So it lies within the sphere. X squared plus y squared equals 9. I'll put the word within it to remind me. And above the XY plane and below the cone, Z equals the square root of X squared plus Y squared. So we have a lot of different pieces going on here. What we have to do is we have to figure out in the spherical world, what on earth that shape looks like. Okay, so let me take this piece of information first. Right, if you're inside, that's a sphere. Isn't a sphere rho equals 3? Are we good? Right, so I'm going to go from 0 to 3. Would that be, are you comfortable with that being the range of the rows? Now, if we take this darn cone and we merge it with the phi guys, I always get these guys mixed up. When you're doing phi, if it was the whole sphere, don't write this down because I'm going to change it. If it was the whole sphere, wouldn't it be that guy? But it's a cone, and the cone they're talking about starts at 45, right, and finishes at 90. So that bit there is taking care of the cone, and that bit there is the end of the sphere. Do you see how those two interact with each other? So that's 2 out of the 3. Now the third one is theta. Isn't a cone circular? Isn't a sphere circular? So in both cases, 0 to 2 pi. So what I've just done here is from all this information, actually that one there doesn't help much, right? But from all the other information that we've got, can you see that we can now describe the limits of integration? Okay. Now, when you want to find a volume of something, can't you do the triple integral of 1 dv? Are you good with that? Now, if I'm going to go polar, doesn't the dv turn into, and I've got it in front of me, but I want to write it down, don't you get that ugly sine rho squared sine phi, then you get the d rho, d phi, d theta, right? Are you happy about that? Is what dv becomes. And that you write down because it's always going to be that. So our volume is going to be the integral, well, 3 of them, of rho squared, the sine of phi, d rho, d phi, and d theta. And since I've written them this way, rho is going to go from 0 to 3. Phi is going to go from pi upon 4, the beginning of the cone, to phi equals pi upon 2, the end of the sphere. And theta is going to be 0 to 2 pi because everything's circular. Do you notice that these are all numbers, which is good? And do you notice that this is a multiplication? So if I was going to calculate this, I would do theta equals 0 to 2 pi of 1, because there are no thetas. Phi equals pi upon 4 to pi upon 2, and just do the sine of phi. And rho equals 0 to rho equals 3 of rho squared d rho. I see nodes. I like nodes. Does that make sense? It's really just the
Yes.
pain of setting up these guys. That's much more difficult than what's happening here, right? What's happening here is just plugging in the numbers in the right place and remembering this is the weird, this is actually the Jacobian of the 3x3 matrix using the spherical coordinate transformations. Now, this one didn't have any X, Y's, or Z's in it, but can we just pretend it was a triple integral of this guy, right? X, Y, Z. Wouldn't you have to then go, because I can never remember, but I'll try my best. I think Z gets replaced by rho cosine of theta. Tell me if that's right, because it's
I
rho
think that's
cosine.
X.
Is that it?
I thought that was X. I can check my notes.
Check your notes. I think this fella has both pieces in it. So it'll have something like the sine of phi cosine theta, and Y is rho the cosine of phi sine theta. And then Z is that. That's my prediction, but don't trust me. Has anybody got the real one handy?
Z is rho cosine phi.
Ah, so the phi was here. How about the other two guys?
Everything else looks good, yeah.
Okay. Now, isn't that's why you have formula in the final? You just have a card with spherical coordinate stuff on it. And so when you see a spherical coordinate, you grab the card and you stick it in. Now, if the function was x, y, z, wouldn't this still be separable? It'd just be uglier. And you might have to do u subs or some kind of transformation like that to solve. Anything about that one that's still not clear before I move on?
No, thank you so much.
Okay.
I can go
Before
find
we-
another one in WebAssign if nobody else has one.
Okay, I'll take yours in a few seconds from now. Just thinking my thought process as I thought there. This is a good example, and you do what you want to do, but here's my advice. Get those nice cardboards that are about the right size and put spherical coordinates and write all the spherical coordinate stuff that you need, right? Cylindrical coordinates, all the stuff you need. This is how a Jacobian works, right? The formula for your Jacobian. Because the things that are doing with formula, me personally, it's easier if they're all on one card each. If you just do a huge list, don't you have to scan through the damn thing and you can't find it? Or it just, for my brain, scanning is a problem.
Could we do
Whatever
like
way you
a,
do it, organize it. Sally?
Could we do a surface area question just to refresh?
Tim kind of got ahead of you, but I'll do Tim and then I'll do yours. That sounds like, yeah, that's probably all we're
Do
going
the
to have
surface
time
area
for.
one.
Surface area, perfect. Okay, Sally, what
Go
you
for it.
got for me? Sally, you're on. What's your question? Or you don't have one, you want me to find one, right? Okay, let's find surface.
Correct, sorry.
Yeah, I'm not making any of these up. It's not even worth my while to try. You really have to pick one because they have to come out nice. Have you got the section number for where the surface areas are so I can find them?
They're 15.5, but you split into part A and part B.
Okay, 15. Oh, I got it. I got 16.7 for surface integrals. That's surface integrals. That's not what you want. It's 15.5 surface area. Right, it's a different thing. Okay. Okay. I got A or B. Which one do you want me to choose from? Does it matter?
Nope.
No. Okay. I'm picking A then. Well, there are only 4 questions in it. Okay. Try to find one that's half decent. No, they're all just as ugly as everybody else.
That's what my mom says about me.
And it would be nice, right? So we're being asked to find the surface area. Let's pick 1, 4. Okay, I've committed to 4 all day. We're wanting to look at the surface 2y plus 4z take away x squared equals 5. And the shape that we're doing is a triangle that joins these points together. So that's basically going to be my area D. So if I do a quick sketch, D is going to be here, here, and here. Now to get to the surface area, you do a double integral over the region D, x and y, and you do this ugly formula, the partial derivative of x squared, partial derivative of y squared, plus 1 dA, right? So that's the formula. This guy is going to be x going from 0 to 2, and y is going to be from 0 to whatever the straight line is. It goes through the origin and its slope is 2, so it's going to be that guy. So I know that my integral is going to go from x equals 0 to x equals 2. The integral is going to go from y equals 0 to y equals 2x. So that's me taking care of the limits of integration. And the function that they're talking about up here comes from there. And what you have to do is you have to rearrange this equation so that it becomes z equals. So it's going to be 5 add an x squared, take away 2y. And so z is going to be equal to 5 quarters plus 1/4 x squared minus a half y. I know I'm being fast, and I apologize for that. It's just a time issue. So whatever the surface that you're talking about, that you're trying to get the surface area, rewrite it as z equals. Are you comfortable about that? This guy z is essentially this fella here. Right? So differentiate this with respect to x, you get a half x, right? And then you square it. Differentiate this guy with respect to y, and you get negative a half, and then you square it, plus 1, and it's going to be a dy dx. So I'm going to be doing this integral here, and it's going to be 1/4 x squared plus 5 quarters dy dx. So far, so good? Right, now I'm doing the integration with respect to y, and basically all you get is y times this, because this is all x's. Evaluated at 0 and evaluated at 2x. So what you end up with 0 to 2, 2x, the square root of 1/4 x squared plus 5 quarters, take away nothing, dx. And Calc 2 integral, would you agree that's a U-sub?
Yeah, with the 1/4 x squared plus 5/4 being
And
your
you're
U.
done. Right, sorry about the rush there, but we are time up. I'll see you on Monday with maybe some good stuff.